Okay, so now we're looking at question two. Now as we have in highlight here, we're going to look at two rectangles that can be combined into a larger rectangle as shown. So that's shown right here. We have one rectangle and two rectangles, and they're combined. And we want to find the area of the rectangle, which is going to be equal to its length times its width. Let's call this distance right here the length, and this distance right here the width. We can see that the width is going to be equal to 4. Okay, right there, 4. And the length is going to be equal to this right here, uh, b plus 6. All right. And so that would mean if we find the area of the length times the width, we're going to have b plus 6. That's the length right there, multiplied by uh, the width, which is 4. And so we're going to try to see, well, is this right here, this expression going to be equal to A, B, C, D, or F, or perhaps even more than one of those. But before we do that, what we're going to want to do is we're going to notice that this is in brackets. So we're going to expand this by multiplying this 4 by 6 and the 4 by b. And so we're going to say this is going to be equal to 4 times 6 plus 4 times b, which is going to be equal to 24 plus 4b. And part of why we did that is because um, this expression looks a little bit different from this expression and this expression, but they're all ways of expressing the same area of these two combined rectangles. And uh, the area of this small rectangle actually happens to be 4b, and the area of this one right here is 6 times 4, which is 24. We could have written it as 6 times 4 also. So at any rate, we're going to look here and we're going to say, well, is this rectangle, is it going to be equal to this expression, 4b plus 6? So we've done this work. We found out what it is equal to. It's got these 3 different representations written in our expressions. And also, I kind of show what it looks like visually, each part of the rectangle. We can say 4b, might think of it added to 24, all right? And we have 4b here, but what don't we have? We have 6. So we have 4b and the 4b here, but we don't have 6. Sorry, we don't have the 24, we have 6. So that is wrong. That is not a representation of this. So let's forget about question A, or expression A. And how about expression B? We have 6b. Well, I don't see SE 4b here. And I don't see I don't see this being equal to that. That's 6b. So this can't be right. So that's not right. But here we have 4 times b plus 4 times 6. And if we looked over here at this representation in blue, or circled by blue, that looks very similar to this right here. In fact, they are equal. So this does happen to be one of the equal expressions. So you could use C to express this these combined rectangles. And then we have 6b plus 24. 6b plus 24. And if you notice that 6b doesn't match there with the 4b. So this D cannot be an equal expression. And then finally, we have this one right here, F, B times 4 times 6. That probably isn't very clear. So let me do that now. B times 4 and B times 6 added together. And if you look right here, that again is just right there. So that is one way of also showing the value of the two combined rectangles. Whoops. So very well, we found two solutions, C and F, by observing that the rectangle can be represented by the area length times width, with the width being 4 and the length being B plus 6. We use this, the distributive property right here, and we multiplied the 4 times the 6 and the 4 times B, as shown right in this example right here. And then we finished simplifying that with 24 plus 4b. And we found again that these C and F were two solutions. All right, that's it for number 2.